Great, so let's just get right into it then. So for today's system design, I would like you to help me design a autocomplete system for a search engine. So
Mhm.
that is the high level problem I'm going to try to solve.
Autocomplete or search engine?
That's right, yeah.
Okay. I don't know why that did it that early. Okay. All right. Autocomplete for search engine. Let's see. So I guess I'd like to start from how do you see a user using this? Or like how is this used in general? Just to understand.
Yeah, for
Uh,
sure.
yeah.
Yeah, so
Mhm.
the main kind of surface here is when a user is interacting with the search engine, like typing text. Okay, when they're
Mhm.
typing text on the client, you are to
Mhm.
send back the top, let's say, 10
Mhm.
common autocompletes.
Mhm. They get okay. Alright. I see. Okay. When a user is typing on the client side, they get comment autocomplete. Okay. So this can be any type of client that might be using mobile, and the search engine could be a part of any product, or it's just one product.
Yeah, so let's say this is we're building the infrastructure for
Hmm.
said autocomplete system,
Hmm.
but that this system could be integrated with, for example, Google search. It could be integrated with, for example, Amazon product search, or anything like that. So we're not really concerned about the specific data there, right?
Hmm.
We can assume that's provided, but this is we're talking about specifically about the infrastructure needed to serve the autocomplete suggestions to any client, which yes does include web and it does include mobile, if that is relevant to you.
Okay. Got it. So I guess I'll first start with how much, like how many users are going to be using this, like concurrently or like in a monthly active basis.
Yeah, so we can say there's about 10 million monthly active
Mhm.
users.
Okay. Um, let's see what else. Mm, so for example, when this product is like first being used and we don't really have an understanding of what's common autocomplete for that, how do we suspect to get that? Um, is this going to be based on whatever product, like for example, Amazon search?
Yeah,
I guess we would fill in things based on what the website or the product is serving. So it could be Amazon relevant products, or it could be, I guess, Google in general. Um, okay. Mm, so just thinking about that. Um, does the common autocomplete get affected by whatever is trending or whatever is um really hot?
it definitely can. It definitely
Mhm.
can. There can be a lot of factors to determine what the ranking should be.
Mhm. Uh, Goodbye. So ranking of um, what kind of factors do we want to rank by? So I guess trending was one of them. So it could be something that's hot. What other factors could affect ranking? Like how many people actually, for example, select something. So like we
Yeah,
suggested something. Hmm.
yeah. So one thing. We can start with we can just start with two things for now.
Hmm.
The first thing is trending. Trending, we can assume there's an external API which just ranks all nouns or all words based on how hot they are externally.
Hmm.
So that's one
Hmm.
thing. Trending is a factor. And the second factor is how many other people are searching the same thing. How many people are accepting that auto complete suggestion.
Hmm. Um, Accepted. Yeah, auto complete suggestion. Uh, okay. So this is what we want to kind of focus on for the ranking. Okay. Um, let's see. How many suggestions do we want to provide, like to the user based on whatever the like max per se?
We can do like five per
Okay,
search. Yeah.
5 suggestions per search. Um, when should this be triggered? Like right on the first letter, or should it be triggered maybe after some delay, or maybe after they write a first word? Just, I guess I'm asking this because to understand how frequently we will be sending signals back and forth to the back end to
Yeah.
get data. Yeah.
Yeah, that's a good question. We can say after the first word. Let's put it that way.
Mhm. Start getting suggestions. Word typed. Okay. Can I think of anything else? Uh, I think each search suggestion, how large do you expect that to be? Um, Obviously not paragraphs, but like how large do we expect that to be?
Do you mean the autocomplete suggestion?
Yeah, yeah, yeah.
We can assume they're
Okay.
average 10 words in total.
Average. From the suggestion. Okay. Mm, all right. Let's see. So I guess what I'd want to probably get at is do since the system will be kind of influenced externally and probably by whatever internally is provided for whatever product page that the search engine is at. So I'm guessing all the trending is going to be provided by whatever's uh, tool wants to use the search engine. Um, I guess this will obviously not be a consistent, like as in it will not get trending right away. It might be eventually, you might get the most trending. So it might be more available. So we just care about search engine providing generally like best suggestions.
Yeah, that's
Uh,
fine.
that,
That's fine. Yeah.
okay. Um, Available. Okay, just wait. Um, let's see. Any other things? Um, I think for now, I think this might be a good starting point. Um, to kind of just flesh out some endpoints. Uh, and maybe how we will actually store some of these words
Okay.
or suggestions. Um, so let's go with rough endpoints. So I guess the first will be search. Um, and then search will be like the straightforward one, which will be whatever they typed or whatever they clicked as suggestion, that will be sent to the backend as a search. So this will take a query, probably something a string that they want to search. Um, let's say we're assuming this is just for Amazon for simplicity, then it would just be the query.
Okay.
But if this was like various other products, then we might have like uh the ID of the product that the search is for. So if this was if this was like Amazon or Google, mm, I mean that's if we're providing search externally from the whatever product is uh so then this would help like figure out okay this is for Amazon search or Google. That's what I'm thinking.
That's fine.
Um
Yeah. For now, we
yeah,
can simplify and just assume that we're always just designing for. We can just presume it's for Amazon for now and not worry about that in the future design.
okay, sure. Assume it's for Amazon. Okay. The other one would be suggestions. So this one would be like a post, and this could be like a get. So um, suggestions would just take whatever query we have so far, and it would return. I forgot to return a list of uh like suggestions. Options. Um, Search would actually return us. Okay, right. So this is something I kind of forgot earlier on. So when we're searching and the user uh, presses one of the things and they actually send the search request, what do we expect to send back to the user? Do we want to send them links uh, like Google does, or send them a bunch of relevant products? I guess in Amazon, since we're focused on Amazon, it would be sending them the most relevant products that they would want to see, and then the other services on Amazon would handle getting all the extra details for that.
I wasn't clear about your question. Can you repeat that?
So I guess, sorry about that. So just to clarify, for the search part, when the user um, submits their search,
Yeah.
what do we expect to return? So, for example, for Amazon, would it be just a list of product IDs that are most relevant?
Yeah, so that's
Uh,
outside the scope of the search engine. So we don't care
okay,
what's returned at that point. All we care about is providing the autocomplete suggestions.
suggestion. Okay, so we don't really care about this part,
Well, you
this
might need to care
endpoint part.
about it for other reasons, but you don't care about what product is returned.
Okay. Okay, so we don't really care about the return part here. Okay. Um, I'll just write it out. All right. So how do we want to mm, do this? So do we want to also track um so I guess we were going to track, for example, uh sorry, okay, how many accepting that article suggestion on it. So I was thinking of starting with some of the schema for this, or like how would the data look like in general, so then we can start also like keeping track of things like how many times a user accepted something. Um, so I was thinking that there might be, do we care about something like a search history, what people actually submitted as a search?
You will need that because you need to. One of your criteria is how many are accepting the autocomplete suggestion to use as the
Right.
weights.
Okay. So, search history. Um, okay. So I guess I'll get into some form of the schema um, to kind of flesh out what the data will look like. One of the things that we'll start with is just like a history of things that users searched. So this could be through some, I guess, does it really need an ID? Uh, sure. So it'll be a search history with some ID, just regular uh, key. There will be some query um, that will be put there, uh, and there will be some kind of weight. Let's say this is um, how many people accepted this. Uh, how many people accepted this suggestion? So I guess searches can have can be keyword or semantic. So are we focusing on both in this engine?
So in this case, we can simplify a bit and say it's keyword focused because
Mhm.
we're only we're only populating the first suggestion after a word is fully typed.
Mhm. Okay.
So we can focus on it for now. Yeah, that's fine. Yeah.
Okay. So keyword search. All right. So uh I was thinking this query would, sorry, it might make more sense as a suggestion. So this would probably only keep track of explicit um, suggestions that we provided, and then they actually like that. Um, I don't know how right now this would fit, for example, if the user just wanted to search whatever they typed in. Um, so how many people accepted this suggestion? That would be one of the history. Let's see. Mm, what else? Mm, for the first word typed. Mm, okay, so there will be ranking of words. Um, are we going to be storing different combinations of, let's say, 10 words, uh, in, say, a like a vector database or something like that that we will pull, or do we want to kind of structure like the 10 most common words into a suggestion? I guess the suggestion has to make some sense as well. So it can't just be like a random jumble of words
Yeah,
either.
it can't be pure keywords, but
Okay.
right, it
Mm-hmm.
can't be. It's the order of the words probably does matter.
Mm-hmm.
What I will say in this case to maybe help this
Mm-hmm.
along is, yeah, it's a keyword based search. You can use keywords to rely on for weights, but the
Mm-hmm.
but the solution like the return suggestions, the order do have to matter. So for this
Okay.
case, you might choose to. I mean, one thing you can do with your schema right now is you say, okay, we have some ID doesn't matter. You have a
Mm-hmm.
string that's a pure suggestion, but you know to produce a, to but one thing you can maybe consider is to produce this suggestion, what would
Mm-hmm.
the user have had to type, right? So for example, would they have had to type the first word,
Mm-hmm.
and then it's very popular, maybe you suggest it, maybe they had to type maybe 8 out of the 10 words, like the first 8 words, the first 8 prefix words of this 10 word suggestion before you suggest it, right? So maybe that's something to consider as well, is like under what condition do you show this particular suggestion and how that might relate to the weights.
Mm, I see. So, mm, okay. So you're saying like depending on what word was typed and when it was actually like how many words have to be really typed for this suggestion to be relevant. Let's see. Uh, wait. So right now we had wait is how many people accepted this suggestion. Um, you were saying how many words would actually have to be typed. Um, how would we model that?
We can use a quick example here to kind of clarify the thought, right? So
Hmm.
let's say I'm on the left here.
Yep.
So let's say we had a query, and the query is A, B, C, D, E, F, and then in our, and we have, and let's not do it that way. Let's do this, make it even simpler. We have 2 words, A and B,
Hmm.
and then we currently have a couple suggestions we want to show. If there's 5 of them you want to show, but I'll just say we'll just have 2 for example. First is A, B, C, 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 and the second one is A, B, C, D. Let's say it that way, right? And so here's the
Hmm.
thing: is how do we decide what order to put these in? One thing we can say is, let's say this suggestion has been accepted twice already,
Hmm.
right? So this has been accepted twice, two times before, times, right? And
Hmm.
this one has only been accepted once,
Hmm.
1 time. So the issue here is, no, it's not an issue. So the way we might tie break these two, the same prefix, is by using some weight, right? But let's say, for example, that we had like, this. Well, this is a worse match than this, even though it has more acceptances.
Hmm.
So we want to weigh this above just the times in this context for keywords.
I see. I see. Um, I guess so. You're saying that there will be like how many times accepted as a weight, but then maybe on the application layer there might be like a bit more. So like how many times does AB actually match that suggestion as well?
Yeah, yeah. So
Or
I mean, so
Mhm.
I don't know. And you probably have more in your schema to talk about, but I'm just letting you know that your schema right now will not be able to accommodate this essentially.
I see. So okay. So right now, if AB was used to query, for example, uh, suggestions that are matching, then they maybe return A, B, C, D, E, Z, C, C. But then we also want to rank them on how many words are actually matching. I see. Mm,
So there's keyword matching and then there's weight matching. One thing I will also say right now, if you
mhm.
want to, continue along, is you can assume there's a ranking service.
Okay. So just to kind of help me along, I can just assume that
Yes,
something
you
will
can
help
assume
me.
that there's a ranking service, and we
Okay.
can dive into that more deeper later if we have time.
Okay. Um, okay. So I guess this would be suggestions, the way, um, how many people accepted this. There was externally API that ranks all words. So I guess um, we will also have rank of this. Um, this might be just some type of int that I guess will be provided by some external API that ranks all the words. Um, so is this ranking individual words or just full text?
Could you repeat that? I'm not sure I understand.
So this API, is it ranking the like full text, like I don't know, sentence?
You mean the API that we
Or
assume exists, the ranking API?
yeah, yeah,
Yeah,
yeah.
it could be any format you prefer.
Okay. Sounds good. Um, hmm. What else do we need in data to visualize? So trends are kind of external. Mm, keyword search. Hmm. Do you see any other thing that we need to model? I can't think of
One thing
anything.
that I do want to
Mhm,
check up on is that we might be missing. Like, I'm not sure about the endpoints. Do we need like? How do you plan on recording
mhm.
that an autocomplete solution was taken?
Oh, right. So, okay. So this was get suggestions. This was the searching part. Um, I guess in the front end, what we could do is when someone searches, like let's say a query, we could also pass in like something where like just lets us indicate that this was a suggestion. So there could be a suggestion ID that could be passed as well. Um, that we generated. So either these are all these are all suggestions that we have, and then we could in the backend just populate like uh add one to this. I
Okay.
guess that's one way. That's I think a simple way that we could do that.
Yep, that's fine.
Um, mm, is there anything else we want to flesh out here? Um, that I might be missing.
Endpoints I think are fine.
Mhm.
We could proceed for now, but we might come back on how we plan on storing the specific strings. But we can move on for
Yep,
now to the architecture. Yep.
yep, sounds good. Um, so let's see. We'll have just a general client. Why can't um, mm, so we'll have some kind of client. We might have multiple. We're just focused on one right now. And we have 10 million active daily active users. So we might put a let's say we have some general things. So I'm just gonna put uh oh, also one other question. I think I missed this initially. Is this something that I'm assuming is global and is we want it regionally?
So the service is available globally, but you might have regional weights, but we don't need to consider regional weights for now. Like, just assume it's global.
Mhm. Okay. So we might use some kind of load balancer, um, or I guess Um, let's see. So we have this globally. We might have something that is going to help us figure out where to hit it, like what's the closest. It could be something like, I don't know, Route 53 that just sends the request either based on latency or just geographically closest. Um, that can help us kind of get those queries closest to the client.
Okay.
Um, then we'll have some kind of API gateway for the public endpoints. Um, so this is just read. Let's put that in black for now. So then we'll have, let's say, a initially we were going to get some suggestions. So we'll have some kind of um, uh, uh, suggestions service. So this can handle retrieving the suggestions that were sent by, like, are relevant to whatever the user searching. Um, and how will the suggestions get those? So what I was initially thinking was we, for example, let's see. Mm, so a user is searching something like AB, um, and it might have a lot of different like strings or suggestions. Something I was thinking was possibly a vector DB that kind of incorporates a lot of the weights that we want. So it could incorporate the accepted times. It could also help us search based on multiple different weights that we might have from, for example, externally ranks. So essentially, this is the type of database that would just take whatever string we put in there initially with additional metadata and just add a bunch of weights to that. So then when we get that um, essentially request from the client to get suggestions, we can send that to the vector database, asking it for the five most relevant. And we would get those five most relevant. We would also get the metadata. So when we retrieve something from this vector database, it would just be like numbers because they're just stored as numbers. But
Okay.
then we can use the suggestions table to actually pull out the actual string version of those. So I was thinking we'd have some kind of vector DB. Um, this could be, I don't know, Pinecone or Kendra. I don't really have specific preferences there, but that's something that I can research given more time. What would be better, but right now, not too sure.
Okay.
Um, the other thing we would need is something that would actually store all the information of the string and the weights, maybe additional. This could be, I was thinking, could just be a document database. So we might have more metadata for each session that we want to store in the future. And it doesn't look like we're going to do many aggregation or joins on this database. So I think it might be better for just availability that we just have a database that could just be uh, no SQL in nature and just be present uh, like more easily and don't have to deal with other things with SQL or relational databases. So I was thinking that this could be just something like, I don't know, MongoDB or Dynamo. Um, I'm also familiar with Dynamo, so I'll just go with that one. So this one, what we do is essentially read from the vector database, say Larry for five most relevant uh, strings. And then once we get that, we will actually ask the DynamoDB to get the metadata plus string of uh, the IDs um, suggestion, sorry. And that's what we would kind of return back to the client. Uh, let's see. How many people accepted this suggestion? So I think that kind of gets a rough
Okay.
understand how we will retrieve them. I think one other thing was the search endpoint. Before I move on, do you have any questions for this so far?
Yeah, so I want to just clarify where the
Mhm.
ranking service fits in here.
Right. So,
Is that for example, is that a separate asynchronous process or is that
mhm,
in
yeah.
this tree here?
So I was thinking of so ranking service would just be something that would happen in the backend uh, asynchronously.
Okay.
It doesn't have to happen on every call because then that would slow down the call. So this could be something that would could sit back here, ranking. Um, and I think we did have some external vendor. Um, so essentially, what the ranking service would do is communicate with the. Uh, let me just put the arrow the other way. Um, it will communicate. Sorry, yeah, it will communicate with the external vendor. It would actually look at updating the ranking in the suggestion. So update ranking and add new suggestions. This would get suggestions. Um, Maybe the vendor is just pushing it to us, or this is something we're polling. Um, there's like trade-offs on both. If we're polling, then we might miss more urgent trending words, like something hit the news. Uh, but that is more like sustained traffic. If we're doing something like push, so that the external vendor is pushing it to us,
Yep.
then we get it right away. So I guess there's a trade-off there, but what would be best if I guess if we want the most relevant trending information at all times, it might be best the vendor pushes it to us, um, and then we receive it and immediately take action. Um, do you have a preference?
No, that doesn't matter.
Um, okay.
One question here is like, you're updating the ranking in DynamoDB.
Yeah.
So is DynamoDB or is the vector storing
Mhm.
the ranking? Because you're querying that vector DB first.
So the so the okay, so what I was thinking is the DynamoDB would just have the suggestion and additional metadata. The vector DB doesn't really need to have all the metadata. The only so the vector DB would have the embedded string and
Yep.
it would have a metadata field that would only contain the suggestion ID. We don't need to store the weights in the vector DB. So essentially when we create the embedding, it would take the metadata as input. So when the ranking is getting suggestions, we would first like update or add whatever needs to be added into the DynamoDB for the new suggestion. And then what we'd have to do is actually update whatever embedding we had originally created in the vector DB. So we first delete that record and create a new embedding which would have the updated ranking. So then when we search whatever suggestions, then we get the most relevant weighted suggestion.
Okay.
And
Okay.
does that answer your
Yeah, that
question?
makes sense. Yeah, so the vector DB is doing the heavy lifting there with matching
Mhm.
the current weights,
Yeah.
which is I guess you're saying is push, or it doesn't matter push or pull from the ranking service. Okay.
Mhm. Yeah.
So
So
that means
yeah,
that you have one vector per search for per suggestion.
yeah. So
Okay.
we would have one vector per suggestion, and that would just be the vector database understanding of it, and it will just give us the IDs with it. So then we actually have some way to get the actual human readable
Okay.
version of that. So, um, Yeah. So that, I guess that helps with the ranking. Um, hmm, do we need to further optimize ranking for now? Not really. I mean, if there was a lot of uh suggestions coming from the external database, I mean vendor all the times, then maybe we could look into something like adding like a queue here so that this ranking can like slowly process all the jobs. Um, do we want to add that in here, or it's like
For the vendor side, we won't worry about that. We don't need
okay,
to worry too much about that. One thing I
okay.
did want to dive in on here about this
Mhm.
about what we have here is what sort of performance characteristics we're looking at here.
Sorry, could you repeat the last part?
Yeah, so what sort of performance characteristics are we looking at here, right? So,
Mhm.
one kind of follow up question to that might be, is this excuse me, is this architecture currently able to sustain what you have written here, the 10 million daily active users? That's the first
Mhm.
question. And then the second question, depending how you feel about that first one, is if you were to scale up the number of users, how many users before the system starts not working anymore?
Mm. So I guess right now the way we have it is I don't think it will be able to handle 10 million. Because right now it looks like we're storing everything into this single vector database. Um, so it all depends on how we kind of separate these suggestions. So if it was, for example, all of Amazon's embeddings, these vector embeddings database would start to get quite large. So we may have multiple like replicas of this vector DB that the ranking system could potentially just push to, because these vector databases are mostly just um, read heavy, and they're going to only get updated from the ranking system. So it might be beneficial to one have uh, so for example this load balancer, uh, it might be helpful to have like a database load balancer that these requests would go to, and then it could deal with forwarding to whatever other replicas of the vector DB we have. Um, I think that's what I'm thinking right now. Other ways to kind of break this suggestions off is based on, for example, using one as like language. So what language are they typing in? Since this might
Okay.
be global, um, it could be based on the category of products maybe they're searching in. There could be a easy like um, way for us to figure out, okay, based on this query, what like product do they really are caring for? So it could be a lightweight um, system on the suggestions service side that could just like detect, okay, they're looking for this category, and then maybe based on the biggest categories, we would have a separate vector database, but most of them can be on the same one. So we can start to chip it away that way as we scale more users. Um, I think that's what I'm thinking. Uh, let's see. So there will definitely be more than one version of this. I just didn't draw
Yeah.
uh, that in.
But would they be
Let's
going to
see.
the same? But would the different services and let's say for example different suggestion services be going to the same DB load balancer?
Um,
I guess the question here is
different.
like you're saying, like one thing concern you had is about the size of the database, but what about the throughput?
Mhm. Right. So this would like help with the latency, but I guess when we're talking about throughput, so we'd have different instances of suggestion services. Maybe each, let's see, suggestion service would have its own, let's see, database load balancer. Uh, hmm. I guess initially we would start off with a single database load balancer. We might have just a few set of vector DB, and they might be in different regions or AZs. Uh, but then if we see that adds a lot of latency, if these are stored in a different area than the suggestion service, then we could add um, these replicas into those like closely to the service as well. So they each suggestion service might have its own set of DB load balancers, or a group of suggestion service might have their own. That might need some another service in between to figure out, okay, which load balancer it needs to communicate with. I think there's services for that, like think maybe Zookeeper, but I'd have to look into that uh, to kind of help figure out what services are available for it to communicate to. Um,
Okay.
so that could help with the throughput, uh, and also making sure that the load balancer is configured to, I guess, uh, so if we care about throughput, and then I guess the load balancer would be best to be based on like which services are like send it to the service that's least overloaded. So that would help. Um, that would kind of maybe slow down on latency, but the throughput would be better. So that's something we could do there. Um,
Okay.
yeah, there
Okay.
might be some other. Oh, yeah, sorry.
Just go ahead.
No, I was just saying like the ranking service could be updating a master vector database, but we could have uh, another uh, replicator that could essentially just handle either replicating the whole vector database consistent like constantly, or just looking at what ranking DB did. It could this all these update embeddings could be put into um like a SNS, I think, or just like some kind of way to let all the replicators know that, oh, this vector database needs to be updated in this way. And then we could have um all of them go to this, and then this could actually handle updating all of the databases um, that are read here. Um, that could be one
Okay.
way as well,
Okay.
uh, just to help speed up. Because if we scale too much and we have too many replicas of database, then it might be a lot for uh, to be handled. Mm, so another thing would be if another way to short circuit going to the vector database would be to see how commonly, or like to see if this kind of suggestion was already made. So there could be a cache at that point when we get, like, if we see that, like, if we see that through logs, okay, we keep suggesting the same thing, then we could then look into adding uh like some sort of Redis, or I don't know, any form of cache. I know this is string search, so it wouldn't make too much sense, but it could make sense if you have so there's like lightweight models that you could use to just do like really semantic related words. So if someone wrote, I don't know, a word wrong, but it really meant the same thing, and two people wrote the same thing, but just one of the spellings was wrong, then there's some like generally correct. So we could use the Redis cache to just send the suggestion back. So that's
Yep.
another way. Um, I think that kind of covers it. So the other one was searching, right? Did you have any other questions before I move there?
No, go ahead. You can talk about that
Okay.
and then we'll wrap up.
Yeah, I think we're at 45 minutes, so I'll just quickly go through this. So the search service, I think what we cared about search service was the putting in when someone would essentially click a suggestion. So let me actually put it above here, and I'll just put this down here. Sorry. Okay, this will go to the search service. The search service will actually search whatever. Um, I guess I'm going to just focus on just updating the new accepted suggestion ID since we're short on time. So this will just focus on updating the the how many people accepted the suggestion.
Okay.
Uh, Now that I'm seeing that, okay, two services are depending on the same table, what we could have is the humanized string version stored in a separate database, and then the weights related to it stored in a different uh, database, so that because the ranking only cares about updating the ranking and doesn't really care about seeing all the other string human format, and the suggestions only cares about seeing the human format. And
Yep.
maybe it would actually, yeah. So I think that might help. Like, so let's put this as the uh, human. Sorry, I don't have a good word for it, but and then Berkeley string weights. So yeah, this, and then we'd update the weight here if we've already know about this. If it's a new string, we would have to update the human string, like add new string. Um, we would also have to get the string ID for it. So that might be a little tricky that I actually missed on the ranking side. But do we want to delve into that or just call it a
No, we're out of time.
yeah, yeah, makes sense. Okay, thank
Great.
you.
Let's talk about that. Let's
Mhm.
talk about that. I mean, where did you start? Where do you think you fell in this one? So some things were good, some things were bad. How do you feel? What was good? What was bad?
So I kind of felt stuck in the beginning. So that's especially around the schema. Maybe because I was trying to think of like, oh, how do we? It's like, if you think about word search in terms of algos, it's like just tries. But then when you think about it in like real context and like this scenario, it's kind of harder. So I was getting stuck. How do you send those words or uh like put them in the schema? The other part was maybe um the weights kind of tripped me a little bit, but then you helped me with the example. So that was nice. I think on the design part, I was a bit more comfortable, but getting the right half of the endpoints or schema was where I was getting most of my time sucked into. Yeah.
Yeah, I think I'm in
Hmm.
agreement with that. I think the main thing here is that time was a bit tight at the end there. That's for sure.
Hmm.
Depending on the kind of follow ups you'll be asking regarding performance, you might not have time to go for the search service.
Hmm.
Um, what I will also say is that you were on a pretty good roll at the beginning in terms of asking the functional and non-functional questions.
Hmm.
One thing that was implied, but I don't think you picked up on, is the fact that these are human words and not random strings,
Hmm.
right? And so
Right.
that means there's a very strong hierarchy of frequency for words. There's a very strong hierarchy for
Hmm.
sentence structure,
Hmm.
right? So there are, and what that means, and why that's important is, I mean, and you're right about the intuition using tries, right? Trees for using, for encoding this information.
Hmm.
I think it just might not have been obvious to you how
Hmm.
that jump should have been to use tries in this problem as well, right?
Yeah.
Um, Now, the vector DB solution is also okay. That's a very offloaded solution to essentially give them what's going on. But here's the thing, right? Is and in the solution and in the problem statement we gave, vector DBs are okay. They're not great, but they're okay. And why it's okay is because there's at most 10. On average, there's 10 words per suggestion.
Hmm.
That's not too bad to encode, right? Where
Hmm.
does that break down? That breaks down to, for example, let's say average is 10, P99 is 100 words, right? Like for like again, right? Generalization, right? This is a search service, autocomplete service we're making. Of course, no
Hmm.
one's typing 100 words in Google search, but what if it's like a documentation search for like some other service, right? Then you might need 100 words to describe it. Whereas the P99
Hmm.
would be 100 words. Well, then that would the worst case performance for querying vector DBs would be very very terrible, right? So you got to keep that in mind.
Right.
Why? So one way you can think about this is, well, why didn't you catch that? So I can't speculate very much, but what I will say is that I think if you assume things, it's good to just check it, right? So for example, are we assuming these are regular humans typing regular human sentences in the search, right? What are the type of things that we trying to do with the search, right? And you had a good intuition about that when you're trying to encode the product ID in the search query. Like, hey, which service are we searching? Are we searching on Google? Are we searching on Amazon? What are we going for? Right? That would have been a
Mhm.
good way to disambiguate what's going on, right? And we simplify the problem, so that's okay. It's okay to get rid of it,
Mhm.
but you had an intuition for that, and I'd say that intuition is actually really quite important, exactly for the reason that we would use a tree in this solution. The tree is, most people consider the tree optimal. You can argue otherwise, but where a tree would look like for encoding this information is each word is a node, right? And then the weight on each node, or you can call it the edge, the edge weight, and you can call it a graph even, right? The edge weight would just be how hot that edge is right now. Why
Mm.
that would be,
Yes.
why that might be preferable is because, look, we are already saying we're breaking out the ranking service, right? The ranking service can very easily, uh, it can very easily update the edge weights asynchronously, right?
Mhm.
Like that, like you could even encode the node values and then edge weights in separate tables if you wanted to even save on that kind of read write discrepancy. But so there's a lot of different ways to kind of solve this problem. A try would have been one of the ones that you could argue for much more easily, because you can
Mhm.
predict that certain words will be grouped together more often. You can predict that your worst case latency is not very bad, because you know having one long word does not affect the performance of all the other shorter words, which is more common, right? Only 10 on average. And one more thing I'll say is, about your specific DB choice here, which is fine. I think there's a couple of things that was missing explicitly, right? Regarding performance, this is right. So this aside from correctness, um, the sharding strategy needs to be a lot more explicit here,
Mhm.
right? So you talked about, okay, you have a load balancer, and you talked about Zookeeper as well, which is great. But we didn't talk about is like, how are we actually using these databases? Obviously, now tomorrow if I say, okay, we have 2x more users, 5x more users, are you just increasing the number of databases? Okay, then what's on the data? Like what's actually in the storage, right? So I think one thing that you could really show interviewers that you know what's going on about these databases is by being
Mhm.
very explicit about the encoding and being very explicit about the sharding, like horizontal sharding, right? So
Like
go ahead.
languages based on that, or like
Yeah, so
uh
yeah, so
mhm.
languages is one thing, right? But is that but and that is one way to shard, but is that sufficient, right? The
Right.
vast majority of the internet right now, at least, is still in English for these search engines. So
Mhm.
yeah, great, you share your languages, and maybe some other languages like maybe French or German, moderate languages, but don't scale as largely, right? But
Mhm.
English is much bigger, and so if all your English sentences are still on one database, that's still not going to work, right?
Right.
and this
Mhm.
and this should be a signal to you. So there's two things that you can notice. The first thing you can notice is this: uh, we need a shard based on the actual sentence or the string, and not just based on some metadata like the language, right? The second thing you might need to notice is that vector DBs might not be the right choice if you have high sharding requirements. One thing you could say, right? For
Mhm.
example, okay, let's say you're storing a vector. We can shard based on the first number, right? First number, or you can shard. Yeah, I think first number would be the most. Like say we shard based on the first dimension, right? Great.
Mhm.
And then that's one way to do it. But what that would mean is that you would have to encode, like you would like before you even go to the DB load balancer, you would have to already make a DB query yourself to figure out what dimension it's on. Like what is the first number? Like how do we encode this search query, which is a string by the way, into
Mhm.
your numbers, right? So that would not be too cheap, right? And let's say,
Right.
okay, great, and now let's say we have shard English even more. So you maybe shard by the first two dimensions, right? So you have 100 databases, let's say, um, right? Well, then that's 2 DB reads immediately off the spot, right? So that's not like super great. It could be okay, but it's not like super great, right?
It,
For example, where a try would avoid those initial reads to improve latency would be that you would just store the strings themselves right in the nodes. All right, and then and there's assumptions you make there. How long are the words? We didn't get to that, but didn't really matter, right? So that would be one part where again the P99 performance would be better because you'd be saving yourself
mhm.
reads before you even do any queries, right? So there's a detail there.
So like using a graph database to store the try, and then in each node you'd have the word ranked or the. the string, like the suggestion ring, I guess.
It would be essentially so two things. It would be the word. Each node
Right.
would be a word, and you would traverse down
To a
the
suggestion.
graph based on the highest like whatever you define the highest lowest edge weights. You know, the best edge weight,
Hmm.
right? And then you find your suggestion that way. Now again, right? So two things there again is why that's more scalable in this context. What I just described is because you can shard a try very easily based on the first the first word, right? Words that
Mm.
start, let's say words that start with S, very common, right? Words that start with S, maybe that's its own database. Words that start with maybe W, that's not common. Maybe actually, what is a common word, right? Like maybe like X and Y Z. Maybe put X Y Z all in the same database. Maybe that one's like not high prio, right? So
Mm.
and then say, oh, okay, great. Now it's now even S is too big. Well, then you can still shard based on the first two characters of the word, right?
Mm.
So that's a much
Hmm.
more natural way, and it's a free way. You incur no penalty on that sharding because you don't need to make any reads to figure out what database to go to ahead of time, right? Like that's known.
Hmm.
So that's one potential benefit, right? So there's a lot of these things that I think would have been worth considering, at least calling it out, right? Calling it
Hmm.
out, and then at least that way the interviewer knows, oh, you know about tries, you know what's going on. You just made a incorrect decision based on some other information.
Right. Okay.
So it's just a balancing that. It's a balancing act, right?
Hmm.
Great, and then let me have a look at my other note here. So yeah, and that what I just said there was mostly about the text properties, right? What are the properties of the text here? If you're going for random words, random strings, then I agree a vector is probably best. Otherwise, the branching factor, the try would be just way too big. But right, but that's something you could have clarified ahead of time.
Right.
Let's take a look here. So another one I had here. This is not as relevant anymore, I don't think, but I put a note down which was that when you were working on the endpoint design, you seem to index a lot on the product ID, which is, for example, on Amazon in this case, right? Um,
Hmm.
we're not really designing the search service per se. Like we're not designing what they're going to return. All we really want is like once they accept one, in addition to what it returns, we want to send a post request or whatever you want to call it, put request to our service, our endpoint somewhere, which will to keep track of this data point. That's it, right? So don't over so be very clear and precise about what we're actually designing, and don't overextend the scope.
Right. I guess I could have just assumed the search was just another API, but then I mixed it with the query actual search and putting the suggestion ID in there. It could have just been our own like update metric or something. I see. Okay.
Exactly. Yep.
Yeah. Mhm.
Great. Okay, that's all on my side. Any questions on your side before we end it?
Uh, mm, no, I guess no further questions. I might follow up maybe later if I have more. But yeah, thank you.
Great. Yeah. Thanks for participating. Then take
Yeah.
care.
Yep. Take care. Thank you.